What you see on the screen here is the way virtualization's been handled for the last 15 years. It works, but it's expensive, it's difficult to maintain, it's complex, there's a lot of moving parts that can fail at any given point in time, usually from a pile of different vendors. What Scale Computing's done that's absolutely unique in the space is gotten rid of all of the unnecessary moving parts. Literally collapsing the stack, getting rid of everything that doesn't need to be there, while maintaining all of the benefits of dedicated servers without their cost or complexity, without their dedicated support. Maintaining all of the benefits of shared storage and SAN without its protocol overhead, without its support contracts, without its cost. Now, the way this is done is very, very simple. We've simply created an active cluster, made it self-aware, built specifically to anticipate failures and work around them so that you don't have to deal with issues. The way this looks is something like you see on the screen. A series of 1U commodity x64 nodes, each node containing cores, RAM, spindles, NICs, built and architected together in such a way that they are aware of everything going on every other node in that cluster. They all share a global namespace of disk built on our own data management engine, striping and mirroring all data across all drives, using two-way replication. Every block of data committed is written to a minimum of 2 separate drives on 2 separate nodes in the cluster, essentially creating a cluster-wide, cluster-based dynamic RAID 10. Now, that's all well and good, but how easy is it and how survivable is it to actually administer an HC3 cluster? Well, let's jump on one. Right here, we're going to jump into the virtualization tab. Notice that this is just a browser window. We'll create a new virtual machine. Let's call it 1.1 alpha. Maybe it's going to be a new SQL server. Choose the version of paravirtualized drivers that's appropriate. Hit next. Choose how many cores, how much RAM. Hit next. How many and what size virtual hard drives. Hit next. Choose our install image, our ISO, and we're done. That virtual machine has been created. It's been instantiated on every node in the cluster. Every node knows about it. When I hit start on this virtual machine, you're going to see Scale's state machines in action. The cluster's self-aware nature essentially goes, looks, and determines, based on load level, where that virtual machine should start and run in the cluster. The administrator doesn't even have to think of it. And there it is. We'll bring up his console here. Live migration with Scale, because we've taken a holistic approach to virtualization, is trivial. Literally, even in the middle of an OS install, the very first time this virtual machine's ever been run, we can already live migrate him in a matter of seconds as he boots up. That's the beauty of Scale's approach. Its elegant simplicity and powerful nature, giving up nothing, gaining feature sets that don't exist anywhere else. Now, to prove the survivability of an HC3 cluster in your workloads, while we install the operating system on this virtual machine, which we just created, started, and live migrated, all in the last 20 seconds, I'm going to go ahead and kill power to one of the nodes in this cluster, taking away 1/3 of its resources. What you're going to see here, well, let me kill power and show you. There. Now I've killed power to node 3 in the cluster, right here. What you'll see is the state machine starting some comeback to life timers, checking to see if It was just a simple network miss. Once those expire, it'll notify you, hey, something's going on, but we're still running off of alternate block copies. Notice it's not impacting performance whatsoever of our OS loads here. Here I'm simply adding those pair of virtualized drivers, slipstring them in during the install so I don't have to live with a bad mouse and bad video like other virtualization platforms. Notice that this cluster has determined that node 3 has gone away, and here over the course of the next minute or two you'll see these virtual machines that have been running on node 3 simply automatically show up here on the other nodes in the cluster. As a sysadmin, this takes the hair on fire moment out of any component failure, allowing you to focus on your workloads, not on your architecture. That's kind of the point of HC3. So without having to spare a thought for the fact that a full 30% of the resource in this cluster has gone away, I know that my HC3 cluster simply will map around problems, automatically repair issues, and allow me to focus on my applications. Notice the performance level. We've already copied our Windows files over, expanding the cabs, and here over the course of the next minute or so, those VMs will simply pop back up, load balanced automatically across the other nodes in the cluster. HC3 is both that powerful and that elegant of a solution. Let me not understate this. With Scale's architecture, you can lose any component, anywhere, at any time, and everything just keeps going. That's the point. Here we see the state machine self-checking, node 2, making sure that it's doing exactly what it's supposed to. We'll launch the consoles for one of those VMs here so you can see that they're absolutely fine. And here in the matter of just seconds, we'll see those other virtual machines that had been on the failed node pop up. And there they are. Any component, anywhere, at any time, and things just keep going.